surds. Okay, so root 2, root 3 and root 5 are all examples of surds. They cannot be written as a fraction and are therefore called irrational numbers. Like with indices, there are certain rules that need to be learnt. The first of which is the multiplication rule. And if we have root A multiplied by root B, it gives us the root of A times B. The division rule, if we have root A divided by root B, I get the root of A over B. Okay, rule number 3 then is when we're adding or subtracting. And to add or subtract with a surd, we must have the same number inside the square root sign. So if we have A root B plus C root B, we simply add the A and the C together, and it's still that amount of root B. If we're subtracting, we subtract the A and the C, and it's A minus C then upon root B still. What important point to note is that if we have the square root of A plus B or A minus B, that we can't simply say that the square root of A plus B is equal to the square root of A plus the square root of B. That will not equal. For example, if we have the square root of 9 plus the square root of 16, that is not equal to the square root of 25. Root 9 being 3, root 16 being 4, adding together gives us 7, whereas the square root of 25 is 5. So please do remember that they are not equal. Okay, simplifying surds then in the first example. So root 48, so we want to split the 48 into the product of a square number and another number, so into two factors. Okay, so 48 we know is the same as 16 times 3, with our 16 being the square number. So we're going to split that into root 16 times root 3, as it was root 48 that we wanted. Root 16 I know is 4, so we can write that as 4 times root 3, and then we can drop the multiplication sign and simply write it as 4 root 3. Part B, 3 terms this time, same principles apply. So 3 root 50. So let's deal with the root 50 first. Root 50, we've got 25 and 2. So root 50 then we can write as root 25, which is 5, times root 2. So root 50 is 5 root 2, which must then make 3 root 50, 3 times that, giving us 15 root 2. With the root 18 then in the second term, root 18 I know is the equivalent of root of 9 times 2. Root 9 being 3, so we can write that as 3 root 2. But we want 2 root 18, so 2 times that gives us 6 root 2. And root 32 we can write as root 16 times root 2. Root 16 being 4 times the root 2, then giving us our minus 4 root 2. So we've got mixed addition and subtraction question here, but you'll see that they all have a root 2, which means we can simply add the 15 and the 6 and take away the 4, giving us 17 root 2 as the answer. Okay, part C, simplifying the root 28 on top. Well, root 28 we can write as root 4 times 7. So root 4 times root 7, root 4 being 2, and 2 root 7. Okay, so 2 root 7 on the numerator, we have a 2 on the denominator, which means we can cancel the 2 on top and bottom, giving us simply root 7 as the final answer. Okay, part D, root 6 over root 3. Well, our division rule here will work straight away as we can't simplify the 6 or the 3. So root 6 divided by root 3 then simply gives us root 2, by dividing the 6 and the 3. Part E, we've got 2 root 3 times 3 root 6, so the multiplication rule, we've got numbers on the outside which we multiply, giving us 6. The numbers inside the square root sign, then we're also going to multiply, giving us 18. But root 18 can be simplified. There is a square number that will divide into that. Root 18 then we can write as root 9 times root 2, with root 9 being 3 times the root 2. But it's 6 root 18 I want, so we want 6 times this, giving us 18 root 2. Okay, expanding two brackets in part F. So just like you would expand any two brackets, we've got root 3 times the 4, giving us 4 root 3. We have got 4